Let's now think about the work done on a frictionless incline. We've got an object on an incline, there's no friction, we're going to slide the object up the incline. Now when we slide the object up the incline, its altitude increases, which means we've done work against the weight. So if we take the vertical distance that the object moves and multiply it by the force we need to overcome the weight, which is just equal and opposite to the weight, we'll find out how much work it takes to get from here to this altitude. We could also think of sliding it in this direction with a force that we used to pull it along this way. And that force, the force that we need to pull at a constant speed from here to here, is going to be equal and opposite to W sine theta, magnitude of W sine theta. That just means we take the magnitude of the vector, of the number of newtons. We don't care about its direction. We multiply that by the sine of the angle theta. And by taking a force equal and opposite to that and applying it through a distance delta s, we also obtain an expression for how much work it takes to get from here to here. It turns out that those two expressions are going to be the same. If we think of this, if we go distance delta s along the ramp, then our delta y is going to be delta s times the sine of theta. If we just look at the sides of this triangle and apply a little bit of trigonometry, we see that the altitude of the triangle is delta s sine theta, so that the vertical distance that we raise the object is delta s sine theta. And in that case, the delta w, the work contribution required to move the thing up the ramp, should be equal to the magnitude of the weight, which is the force that we have to exert in the vertical direction, times delta y. And of course that's going to be magnitude of the weight times delta s sine theta, which is equal to delta y. Now, if we think of sliding along the ramp, we go the full distance delta s, exerting a force magnitude of w sine theta. Our work contribution will be force magnitude of w sine theta times delta s. This expression and this expression are the same, because again delta y is just delta s sine theta. So we see that no matter which way we look at this, as lifting against gravity or as sliding up an incline against a component of the gravitational force, we get the same amount of work. So the idea is that between this point and this point in a frictionless position, there is some amount of work that's inherently associated with that change in position.